Alright, in this tutorial I'm going to show you how to use the rigid body constraints and show you what each rigid body constraint does. Alright, the first one we're going to start with is the first one on the list, which is a fixed rigid body constraint. Now, rigid body constraints have to be applied to rigid body objects, so I have a floor plane here that's a rigid body passive object. I have a cube here that's an active object and it's set to 100 kilograms, and then this one right above it is set to 50 kilograms. Now I'm going to connect these two cubes. So with one of them selected, I'm going to shift select the other one and then come up here to object, down here to rigid body, and then come down here to connect. Now that creates this rigid body constraint right here. Now the default is fixed. So since we are doing a fixed example here, I will leave it set to fixed, but you have all these other versions. Alright. So now what do you think it's going to do if I click play? They're going to fall together and they're going to be fixed with each other. Pretty much like it sounds. It basically just connects the two rigid body objects, and you can actually set it so that the connection is breakable. Well, if I click play, it breaks, and then the cubes fall into each other literally because collisions are disabled. Let me change my frame range. See, they fall into each other, actually through each other, intersect each other, and that's because this is checked right here where it says disabled collisions. If I uncheck disabled collisions, let it cycle through, now they fall against each other like you would imagine. Now if I uncheck breakable, obviously the link is not going to break. Alright, now I'm going to leave it on breakable, but I'm going to set this threshold, because this threshold is the amount of impact required to make the link break. I'll set it to 100. See, it started to hold up the cube just ever so slightly, and then it broke. I'll set it to 200. Almost was enough to keep it from breaking. Set it to 250. Even closer, set it to 300. Alright, there you go. You can see how the threshold works to control how strong the connection is before it breaks. Alright. Alright, now we're going to change this a little bit. We'll set this back to disabled and turn off breakable. And we'll change it to point. Now point is kind of like a hinge in a way, but it's more like something dangling from something else. Now, if I was to click play right now, this top cube is likely going to fall and pivot from this point in relation to this cube. Well, it's falling almost straight down, so I didn't really do it too well, but let me change the frame range so you can actually see what's going on. Now typically when you are using point, this keyframe is going to be parented to one of the cubes. In this case, I'm going to press Shift S, cursor to select it, and then I'm going to select this, let me put this in wireframe. I'm going to select this constraint, this point constraint, and press Shift S, selection to cursor, and then with the constraint selected, I'm going to Shift select the cube and press Control P to set the constraint, basically to parent the constraint to the cube. Alright, now when it falls, the pivot point will be the center of this cube. So you're basically, where this constraint is, that's the pivot point. I'll put this back in solid view. Now it's fallen over to the left, but it will actually fall over in any direction, and I'll show you what I mean. Now I'm going to go into right side view, and then I'm going to basically select all of it and then just rotate it ever so slightly, just a little bit. Now it should fall basically over this direction somewhere. Yep, there you go. The point constraint works good for making some suspension parts on cars, and like making rigid body ropes and chains and stuff like that. Not it doesn't work as good with chains, but I actually meant cables, rigid body ropes, rigid body cables. You can use it to make chains, but it doesn't work as good as hinges. All right. All right, now we are going to change this to a hinge constraint. The hinge constraint, it's used quite often on car suspension systems, or even if you have a door that you need to be a physics object and you want to be able to open and close it, the hinge constraint works well. Now the hinge constraint is exactly what it sounds like. It creates a hinge effect. Now it rotates around the hinge motion, rotates around the z-axis. In this case, the z-axis is running straight up and down, so one of these cubes could move like this. Alright, now I'm going to basically rotate this constraint on the y-axis. Rotate y 90. Alright, now the z-axis is pointed out this way. Now this top cube can only rotate this direction, like that. And of course it's going to rotate based on the center point of this constraint. Now I'm in side view. If I press play, see it's going to fall, and here's the center point. Of course it's disabled, so it's similar to a point constraint, except it limits the rotation only on the z-axis of the constraint. And again, wherever this constraint is at in relationship to this, that's where the wherever this is at the start in relationship to the bottom cube is where the joint is going to be. Now it makes more sense if you do like I did before and you press Shift S to move this constraint to the center of mass of this cube, and then press Shift Select and then Control P and set parent to object. That way this constraint is parented to this cube, and now when you hit play, this is always going to be the center point, and it's always going to rotate only on the z-axis in relationship to this. I hope that makes sense. It's very simple and it should make sense. Alright. Alright, now there's one more setting that's important when it comes to this hinge, and that's your angular limitations. Now, to show you what I mean, like right now with this turned off without it unchecked, then there is no angular limitations. Basically this will rotate around it in a 360 degree motion if it doesn't impact any object that would stop it. Now it's impacting the floor here, so the floor is stopping it. Alright, now if I was to set this to 40, it's minus 45, which means it's about right here is where it could swing to, and plus 45, which is about right here. Now if I was to click play, you'll see it follows this way, and it's going to stop about right here, and then it just pulls the other one over because the top one has enough mass to tip over the bottom one. Grabs, yeah, see what I mean? Simple enough. Those come in handy too when it comes to suspension parts. That setting does. Alright, now the next constraint, which is a slider constraint, I don't think I have ever used this, and in fact I had to look it up to make sure I understood how to use it. But essentially it locks another object to another object except on the x-axis, and it's the not the rotational axis but the linear axis. And you can set limitations right here for how far it will allow it to move. Alright, now let me I'm in front side view. Now it's the x-axis is already going up and down, so let's say if I was to keep it at the default, and let me put it in solid view so you can see it better. If I was to keep it at the default with disabled collision selected, since the x-axis of the constraint is going straight up and down, this cube will presumably fall intersect with this cube. Yeah. Now, let me put this on a slight rotation. Now, my guess is it will kind of hit catty cornered, but it would be kind of like these are locked together in rails, but this cube's still allowed to fall towards this one. So I mean, it locks it in except on the linear x-axis. All right. So if I was to set a limit like -1 + 1, that means these two cubes are going to fall together. But whenever this one hits, this one's going to continue to fall another 1 meter because this is set to 1 meter, and then it's going to lock. Simple constraint. I have not found much use for it. I don't think I have ever used it. I may have used it once. No, I actually have used it once, and that was on a piston motor animation I made, but that's been several years ago. But anyway, this is a simple one, and not a whole lot to explain about it. These settings work the same way as it did in every other constraint. Alright, now I'm going to press Control Z a couple times until this gets straightened back up. And now we're going to go to the generic. Now, the generic is generic. I mean, I don't use the generic because it's another one that I don't have much of a use for. The generic it functions almost identical to the piston, except it does the same thing on all the axes and rotational axes. Basically, the settings work the same. Like if I was to duplicate what the piston did, or what the slider did, all I'd have to do is just go to the angular and the linear and set everything but the x-axis to 0. Now it's going to act just like the piston constraint that I just showed you. See? Now, the only difference is the settings that I'm using for the piston that made it work like the piston constraint, I have those settings on the other 2 axes plus the other 3 rotational axes. Again, this is almost useless in my opinion. I'm sure other people has uses for it, but I've never had a use for this one. I have never once used this constraint. So I'm not going to spend any more time on it because, quite frankly, I don't think it's useful. Now, on to my favorite constraint, the generic spring. This one I have used so many times, and it's a lot like the generic constraint, but the difference is these settings have a spring effect to them. You have a limitation, but you have a spring effect. Now, these settings are set the same as it was before, so if I click play, it's going to act exactly the same. But down here, I have a whole lot more settings. I'm going to take the x-axis, because right here, we are allowing it to drop these 2 cubes to collapse 1 meter closer to each other. Alright, so I'm going to add a spring effect. Right now I turned on the x-axis linear, and if I click play, you don't see much happen. That's because these cubes weigh enough to where this amount of stiffness and this amount of dampening doesn't do anything. Let me set this to 100. It's probably not enough still. No, it barely slowed down the top cube. Let me set it to 1000. Now you can see how this would be used for suspension. It's just bouncing along there, but of course a suspension system would not bounce that much. It would have more dampening. So in this case I'm going to add 10 dampening. That's not enough, 100. And what the dampening will do is basically dampen out some of the bounce, which is what it's doing. But if you watch real close, this cube is bottoming out the spring. It just comes down and bounces, hits hard. Now I'm going to increase this limit right here to, let's say, 2. And see, it eventually is enough to catch it, because you would want a longer spring movement on like a monster truck. And of course, if you want that to have a stiffer spring, just we'll make it twice as stiff by changing 1000 to 2000. But keep in mind, whenever you make the spring stiffer, you usually need to add more dampening, because you can see it falls, it bounces several times. The idea, if you're making like a car suspension or monster truck suspension, you want the spring to absorb the impact, and then the dampening to be strong enough to dampen out the spring, so it doesn't spring back up all crazy. So I want to set this to, let's say, 300. Let me change this to 100 so we can see it cycle quicker. See, now that's actually pretty good. That's more realistic of what I would expect from a monster truck suspension system. Of course, every time you change something, like the weights of this cube right here, it's going to change the numbers or the settings you need here. Now the settings I have on the x-axis here, because you can see the x on this constraint going up and down, right? Now these same settings that we set here can be set for the y-axis, z-axis, and then rotational as well. Alright, now to move on to the last rigid body constraint, which is a motor constraint. The motor constraint is also one of my favorites. It's what it sounds like. It creates a rotational force between two objects, and it does it only on the x-axis. So whichever, like right now the x is basically going up and down the x-axis of the constraint. So when this is turned on, the rotational force would be like we're looking down. It's going to rotate this direction. So it's going to basically connect this one to this one, and this cube's heavier, so this cube is what's going to actually spin. So let me go ahead and click on angular. Now it has a linear motor effect, kind of like a linear motor or a piston type effect like you would use on a hydraulic ram, but it's going to work exactly the same as this, except instead of it being a rotational force, it's going to be a linear force. So I'm only going to give the example for the angular because I think that's the most fun anyway. Now if I set the target velocity to 1 and max impulse to 1, what you're going to see is the cubes fall into each other and nothing really happens. And there's a reason for that. Let me put it in solid view so you can see it better. The reason for that is because collisions are disabled. I'm going to go ahead and turn off collisions, or turn off the disabling of collisions. So now see they fall on each other, and now you can see them kind of twisting apart. Let me change this to 250. But see, there's not really enough strength between the two. This motor, this constraint, doesn't have enough strength to really rotate and overcome the friction. So let's turn up the max impulse. Max impulse, you could think of that as torque. Let me set this to 10. Now that's definitely enough to overcome the friction of the cubes. And this top number is the target velocity. Alright, now if I was to, if you want to think about it this way, this is, let me do this a little bit different so you can actually kind of see what I'm doing or understand this just a little bit better. Rotate onto the side and then G for grab and then just move it down like this. Now imagine this cube right here is like the axle of the car, and then this cube is the wheel. If I was to click play, nothing's happening, but that's because it doesn't have enough strength to turn a square wheel. So let's go here. I select this constraint and then set the max impulse to 1000. See, it's causing this cube to rotate on the x-axis, but it's pulling away from it. And the reason why it's pulling away from it is because we need another constraint. We need, in my opinion, a hinge constraint, because we need to also lock this cube to this one while creating a rotational force. So with this constraint selected, all I'm going to do is press Shift D, enter, and then I'm going to change this one to a hinge, and since the hinges use the z-axis as the rotational angle, I'm going to basically take I'll go on the front side view, and I'm going to rotate this on the z-axis so the z is pointing directly this direction. Rotate Y. Alright, now if this is correct, this cube should rotate, but it should rotate around this because it's locked to this axle. It's like this is a wheel and this is an axle. Oh, well, see, I messed up there. I need to turn off this because that was carried over from when I duplicated it. See, now you can definitely see how this could be used to basically as a motor to make a vehicle move. Axle and wheel. Of course, you have to use both the motor constraint and something like a hinge constraint to make it work. But I hope this explanation was useful. I know I don't always explain it in a very good way. I hope I didn't confuse people too much. But anyway, later people. Oh, if you have any questions, leave a comment below and I will try to answer your questions. I guess that's it. Later people.